Hi guys, today I would like to do a bit of linear graphs. Linear graphs are basically a straight line on a graph. And usually they have a certain kind of direction and they have a certain kind of like how much they increase, what rate. So one might increase, so every one will increase by one, or every one will increase by two, or every one will increase by half. So linear graphs are very useful for plotting data of all kinds of sorts, and they're useful in maths and all sorts of things. So what a usually a graph looks like, a linear sort of graph looks like. So if we get an equation, so if I get my pencil and start drawing, so y equals x. Now, if y equals x, if we draw like a simple graph, so as you know, this is the x-axis, and this is the y-axis, and we'll put like little dashes to indicate the unit. So y equals x. So when x equals 1, y equals 1. So that'll be there. When y equals 2, x equals 2. Right there. And when y equals 3, y equals 3. And there. And it kind of goes in a negative direction as well. And we can plot this, so we can do like a line. It goes through 0, because y equals 0. Something like that. That's a terrible sort of line, but in reality, it's just perfectly straight. There's just no curves or not with a linear graph. Yeah, that's good. Well, if we do another one, we do y equals, let's do 2x plus 1. So what we need to know, right? So if we plug in the equation, so let's say x equals 1. So what we do, if we know x is 1 here, so we need to find what x is. What y is, sorry. So if we put 2 multiplied by the x unit you've chosen, times it by 1, plus 1. And this can give you y. And if we just, 2 times 1 is 2, add 1 is 3, so y equals 3. So if we indicate there, y equals 2x plus 1. If we find what y is at 0, let me just, oh no, it's alright. If y equals 0, sorry, if x equals 0, what does y equal? So if we do this, y equals 2, 0 plus 1. 1. Now we know 2 times 0 is 0 plus 1, 1, so y equals 1. So we find 0, which is about here. This is 0, and we plot it here. And as you can see, it makes a similar sort of line to, well, it will make a sort of similar line to 2x plus 1. But if we do another one, let's do minus 1 now. So we'll just get that there. Yeah, just stick these. Minus 1, minus 2, minus 3. So if I get it, so y equals 2 minus 1 plus 1. So 2 times minus 1 is minus 2. But then add 1 is minus 1, so it's minus 1. So if we find minus 1, yep, so minus 1 is about here. Now, you can see sort of a pattern, it's a straight line. Now, remember, not all equations will do this. If you find 2 or 3 points, it don't mean, oh yeah, you can just draw a straight line. No, only if it's got a 1 multiple of x, and it's just got a unit or no unit, whatever with it, plus 1, then yes, it will be a straight line. So with these 3 points, I can just draw a straight line like this, like that. There we go. Now, there you go. That's how you can plot linear graphs. So the basic thing with linear graphs, you can just take 2 points, work out 2 points, and then you can draw the graph. Just draw it as a straight line in whichever direction and magnitude the points are. Okay, cool. Right. Now I'd like to show you something else about linear graphs. Well, actually, before I delete that, you notice here, right? Sometimes we want to work out the intercept. So when we work out the intercept, basically we're making the graph equal to the graph that is intercepted, because we know at that certain point of y, it will intercept the graph at that certain point in x. So the x and y coordinate are the same for both equations. And what you can do that to represent that, if y equals x, if y equals x and y equals 2x plus 1, we can then do x equals 2x plus 1. Sorry, it's a bit messy, I apologise for that. So what can you do with this? Well, you can rearrange it, can't you? So if we rearrange it, so if I put, if I minus 1, if I minus 1, so x minus 1 equals 2x. So I've basically moved the one side, minus 1 from one side, so I have to minus 1. That is very terrible. Let me rub that out and do that again. Delete. Yeah, so it's x minus 1 equals 2x. So now then we can minus the x on this side, because x here is positive, it's not negative. The negative is the minus 1. So this is the negative, the minus 1. X is the positive, so we minus the x. So when we take it to this side, we minus x from 2x. So then minus 1 equals x. So we know that at a certain point, so we know that the intercept will occur at minus 1 for x. But now, if we plug that into the equation, well, if we do y equals, you can plug it into any. In fact, we'll do it for both, so we can just prove the point. Prove the point that y will turn out the same. So y equals x, y equals 2 plus x. So for 2x, so we know y equals minus 1 because there's only one x. So y equals 2 minus 1 plus 1. So you can see 2 times minus 1 is minus 2 plus 1, which is minus 1. So do you see there how we can prove that the intercept is a certain x and y value? Yeah, cool. I hope so. I've got another example. Yeah, I'll use something else now. Well, if I got this, if I delete this, it's just in the way a bit. Alright, we're just gonna so if I got something on the internet, no. If I got some internet, so I've got Desmos up. This is a good graphing calculator. So let's try and work out the what should we work out first? Well, let's work out the first equation. So y equals 2x plus 5. So y equals 2x plus 5. And the second graph is y equals x minus 2. So they are both linear. They are both linear equations, so don't worry about it. There's no like catch here. So y equals x minus 2. Now, I want to find. So what I want to find is I want to find the x value when y equals 0. I want to find the y value when x is 0. I also want to find when they intercept, because they do intercept at a point. So we'll do y equals 2x plus 5. So let's make y equals 0. So when y equals 0, 2x plus 5. Move the minus 5 to the other side, so it's minus 5 equals 2x. And then divide by 2, which is minus 5 over 2 equals x. And that's about minus 2.5. Now if we check our graph, sorry about that. Check our graph. As you can see there, so the first value is the x value and the second value is the y value. Because we put y as 0, and our x value comes out as minus 2.5. So cool. Now I would like to work out when y equals when x is 0. So this is usually quite easy, this one. All you have to do, y equals 2 times 0 plus 5. And that equals plus 5, doesn't it? So that's easy, because 2 times 0 is 0, plus 5 is 5. So the total is 5, y equals 5. And so it's obviously, you just have to use this, basically, because 2 times, because the x will be 0, and whatever it's multiplied by will be 0. So yeah, it's plus 5. And does the graph, does Desmos agree? Yep, 0 is x and 5 is y. Now let's do this other equation. Sorry, it's really messy. So let's do it when y equals 0. So 0 x minus 2. So we move the 2 to the other side, so it's add 2. So x equals 2. And so when y equals 0, is it plus 2? Why yes, look. So 2x 0y. And then if we now do the x value, the y value, sorry. It is, so y equals 0, because 0 is 0. It's we're looking at for the x axis minus 2, and that equals minus 2. And then if we check the graph, is it y equals 2? Yeah, definitely. So 0, 2, minus 2. So yeah, coming along well. Now, because it's so messy and huge, I'm going to have to delete this. But we've worked out those values, we got them correct. Now, what about when the intercepts? Well, kind of remember, I think it's x minus 2 equals 2x plus 5. Now, to work it out here, so if we move minus 2, so if we add 2, we get it's x equals 2x plus 7. And if we move the 2x over to the other side, so it's minus x equals 7. But if we flip them, if we move this to this side and move that to that side, so we can get a positive x equal minus 7. And then if we want to find the y value, so minus 7 minus 2, so y equals, if we put in this equation, 2 times minus 7 is minus 14, plus 5 is minus 9. So it comes the same thing. And if we check Desmos, we can see here, let's click it. So yeah, when the intercepts, it's minus 7 for the x coordinate and minus 9 for the y coordinate. And there you have it. That was quite simple for a linear equation, but that's the basic principle. And I hope it's been useful. I'm going to try and do some more videos that will be helpful. Maybe I'll go to quadratics. And yeah, I hope you all have a wonderful day. Take care.